So I think you guys could probably agree with me that graphing and trying to find the solution was not the most efficient thing to do. If you were kind of lousy with your graphing, or if you misplaced a point or didn't count slope right, you would get the wrong line. They wouldn't cross where they were supposed to. If you weren't using a ruler, there wouldn't be an intersection at the lines of the graph paper. Or God forbid, like we saw in that one worksheet, they crossed in the middle between lines, and our job was to try to figure out what those numbers were. So that's not a very good way to try to solve a system. So what we're going to teach you today is how to solve a system algebraically. So we are in lesson, I think 8. Yep, lesson 3.8. And that's going to be solving a system of equations algebraically, so that means just doing math. And the technique that we're going to use is called substitution. And today's date is 2/5. Now, there's multiple strategies to how to solve a system of equations algebraically. Your book only focuses in on this one. Next year, you'll focus in on the other strategies, okay? And each strategy gets used when it's most appropriate, okay? So I don't always use substitution unless the problem is set up for me to do it. There's other strategies called elimination, and I don't use elimination if substitution is there, because substitution is the easiest one to do. And elimination may require more work. So again, all these different strategies, you have to kind of look at the problem and say, well, what would be the best strategy to use? But again, for us, all we're going to do is substitution. So let's put down a definition of what do I mean by substitution. I believe we've talked about this word before. It's not the first time you've ever heard it. So what is substitution? Substitution is replacing a value with an equal value and solving what remains. We've done substitution when you've had, here's some numbers, could they be the solution to this equation? And you would substitute one number in at a time, calculate out, and see if what you have on the left was equal to what was on the right. And sometimes you got something that was true, so that meant yes, it was a solution, and other times you got no, and it was not a solution. I've been sharing with you that you can always take your ordered pair you think is the point of intersection, and you can substitute in the x and y values to your equations to see if it satisfies the equations, making what's on the left equal what's on the right. So we've done this notion of substitution before, okay? So basically what you're looking for is a system, okay? So here's our key here. Look for an equation in a system of equations that is solved for one variable. Okay? So we're going to look for an equation in a system of equations that is solved for one variable. Okay? Now, ideally, that means we're going to have an equation perhaps written in slope-intercept form. So we're going to look for something perhaps in slope-intercept form. Now our notes aren't going to be terribly long today, so what I'm going to do is we're going to do an example of a problem where one or both of the equations are solved for one variable and show you how substitution works. And then we're going to talk about, well, what if the equations, neither of them are solved for one variable? How are we going to use substitution in that situation? Okay, so let's go ahead. We're going to do an example. And because we have so little, I think we can fit everything on one page today. And so if you left a blank page, that can be for the homework for tonight, because we are not graphing, so that's kind of nice. So here's our example. The direction is going to say solve the system of equations algebraically. And honestly, whether this is the most efficient way of solving it or not doesn't matter. The strategy we're going to be practicing for the rest of this chapter is going to be substitution. Now, I like to use color coding when I'm doing my math, especially when I'm learning something for the first time. And so that might be helpful for you just to have a color on hand when you're doing your homework, okay? Because it's going to help you track things. So here's the problem, an example of a problem. Maybe we'll do a couple of them. Y equals x minus 3, and y equals negative 2x. So do I have an equation in that system that is solved for a variable? That's one variable by itself. Yes or no? Okay, Dylan says no. Anyone say yes? Okay, well, I'm not hearing yeses, but I'm seeing an almost imperceptible nod of his head from Jaden. Going slightly like one of those doggies in the back of a car that the head kind of just slowly moves as you're driving. So, Jaden, what variable do you see that's by itself? Okay. Now, it's not by itself because it has a 2 attached to it. Okay.
Oh, the x minus 3.
Okay. X minus 3, no, there's a minus 3 attached to that x, so it's not alone. So what you should notice is that the y is completely alone. And it happens to be the case for both equations. So basically what I'm told is y equals two different things. It equals x minus 3 and it equals 2x. So if I have two ways of writing y, and they both happen to use the same variable x, what I'm going to do is substitute in that value that represents y from one equation into the y for the other equation. That's what substitution is. So now what I have for an equation is 2x equals the rest of that equation, x minus 3. So my job now is to solve that small little equation. So what am I going to do first? Oh, I can't divide. Division is not acceptable when I have more than one term on a side. Okay, what am I going to subtract from both sides?
2x.
Nope. If I subtract 2x, I take everything to one side and I get 0 on the other. That doesn't make sense. Yeah, we want to get the variables together, so let's subtract x from both sides. And that leaves me with x equals negative 3. So this answer here is now part of my ordered pair solution. It's the x-coordinate of where the two lines intersect. Okay. So I'm off to the side. I'm going to write some steps. So first thing we did is we identify one equation that has one variable alone on a side of the equation. So that was our first step. Next, I substitute what that variable equals into the other equation as the, let's see how to say that. So substitute what that variable equals into the other equation. Let's do it this way. replacing the matching variable. So if I have y equals 2x, I'm going to take the 2x and I'm going to replace the y in the other equation with the 2x. So what I'm doing, and the only way that I can solve an equation with two unknowns, is to get rid of one of the unknowns. And that's what substitution allows me to do. I created an equation that had no y's in it anymore. All it had were x's. So now I'm going to solve the remaining equation for the remaining variable. In this, our case, we solved it for x. That is now half of my solution. That's half of the point of intersection. I got to make sure I put it in the right spot. Now, my ordered pair needs an x value and a y value. I got the x value, so what do you think I'm going to do to figure out the y value? What would I do, now knowing that x equals -3, if I wanted to figure out what the y coordinate of this solution was going to be? What do you think I would do? Well, what's the name of this strategy we're using? Substitution. So guess what? We're going to do substitution again. This time, now that I know that x equals -3, I'm going to substitute it into one of the equations and figure out what y equals. Does it matter which equation? No, it really doesn't. And in our case in particular, it really doesn't matter because both of our equations are y equals and then something we need to plug into. So I tend to pick whatever number or equation I think would be easiest for me to solve. So I'm going to pick this one. And I'm going to say that y equals 2, and then I'm going to substitute in -3 for x. And I get y equals -6. So that becomes the y coordinate for my solution. So where my two lines cross is at -3, -6. So we can write this as our last step. Substitute the answer into, I'm probably going to have to write in a crazy way, into either original equation. I'll put it over here. And solve for the other variable. I'm not going to solve for x again. I already got it. I need y now. Substitute the answer into either original equation and solve for the other variable. So to check my work, I'm going to substitute in -6 for y, and I'm going to substitute in -3 for x, and see if what's on the left equals what's on the right. And I get -6 equals -6. So it satisfied the top equation. Now I'm going to try the second equation. Is -6 going to be equal to 2 times the -3? And I get -6 equals -6. So since it worked for both equations, that means I did actually find the solution to that system. And all I've done is used substitution. Okay? All right, let's do one more like that without the explanation next to it. Everybody ready? Can I move? Let's do a second one, and then I'll give you a, well, what-if situation. So let's do y equals x plus 4. And y equals 2. I think I already know half my answer. What would half of my answer be? And which one is that? Y. So I actually already have half of my ordered pair, and I get that from this equation here. It says your y value is 2. Okay, that's easy. So what makes the most sense is to take that value of 2, and because my y's match, it says you can take that 2 and substitute it in for y in the other equation. So we get 2 equals x plus 4. And now I need to get x alone. So what am I going to do to get x alone? I could subtract x.
Subtract 4.
Okay, well, if we made this commitment, we're not going to subtract 4. Now what? We're going to subtract 2 from both sides to get the constants on the right. And we get negative x equals 2. Am I done? No. I've got a negative x, so I need to multiply or divide both sides by negative 1, because 2 negatives make a positive. Over here, the signs are different, so my answer is negative. So my second answer is going to be x equals negative 2. And then I can quickly check and see if that makes sense. So I've got, does 2 equal negative 2 plus 4? Well, I get 2 equals negative 2 plus 4, signs are different, so I'm going to subtract bigger number is positive. So I get 2 equals 2. Yep. And then what's interesting on the second equation, when I substitute in 2 for y, I get 2 equals 2. So, yep, it matches. All right. So what if we get something, in fact, I just want to briefly look, hold on. The last question, or example, is going to look like this. The last two were kind of nice. They both were solved for y. This one we're going to do a little change up. And I just looked at your homework, and pretty much every problem has one equation that's solved already for one variable. But, like in this example, the second equation is not solved for that variable. So this kind of makes it a little bit obvious what I'm going to substitute. I don't have to make a choice. So the only equation that has a variable by itself is the top one, and it has y by itself. So what it's saying is that 3x plus 8 means the same thing as y. So what I'm going to do is substitute that expression, 3x plus 8, just in place of the y in the second equation. Everything else from that second equation stays the same. I still have 8x. I still have plus. I still have 4. You can stop tapping. But instead of writing y, I'm going to write 3x plus 8. And then I write out the rest of the equation. All right, how do I solve an equation that looks like this? What's the first step? Yeah, I'm going to have to distribute. So I have 8x, and then I have plus, and then I'm going to multiply 4 times 3x is going to give me 12x, and positive 4 times a positive 8 is going to give me a positive 32. And then that equals 12. Okay, what am I supposed to do next? Our card of equation solving, Savannah? We're going to combine like terms. And what you should notice is I have 8x and I have 12x. So I'm going to combine them. What's 8x plus 12x?
Well, 16.
It would be 20. Plus 32 equals 12. Now what? Say again? Subtract. I heard 34, that's why I asked. I'm going to put it up on the top since 32 is actually bigger than 12. So when I do the subtraction, it makes more sense. So I'm left with 20x equals, signs are different, bigger numbers negative. 32 take away 12 is 20. All right. The last step to get rid of multiplying by 20 would be to divide by 20. on both sides.
1.
Not 1.
Negative 1.
Signs are different, so I get negative 1. So that is half of my solution. So the x-coordinate is negative 1. Okay, there needs to stop be whispering. If you guys have questions, you need to bring it up to me. Okay. Now, I need to figure out what y is. And I can substitute it into either equation. However, one of them is going to be easier and faster for me to figure out what y equals. What equation should I plug that x equals negative 1 into? That's going to get me the answer super fast. The top one or the bottom one?
Top 1.
Yeah, top one, because it's already set up to solve for y. So we're going to get y equals 3, and then our x value of negative 1 plus 8. So that gives me y equals, when I multiply, I get negative 3 plus 8. And negative 3 plus 8 equals positive 5. So that becomes the second coordinate to my ordered pair. Now the check gets a little bit more cumbersome because there's more math to be done to do the check. Okay, Sophie, if you have a question, ask me. Okay, oop, I wrote a negative 5. It's supposed to be a positive 5. Okay. So our y value is 5 when our x value is negative 1. Now, instead of acting all bored having to write this down, think about how lucky you are that you can know if you have the answer right or not, instead of waiting for a test to be graded. You should already know the answer because you've checked it. So 3 times negative 1 is negative 3. And then negative 3 plus 8 is 5. So 5 equals 5. So it satisfied the top equation. The big test is going to be the bottom equation. So then we have x, or 8 times the value of x, which is the negative 1, plus 4 times the value of y, which is the positive 5. And we want to know, does that equal 12? So we get negative 8 plus 20. And that equals 12. And see, negative 8 plus 20, the signs are different. Bigger number is positive. When I subtract, I get 12 equals 12. So that says that satisfies. So what I've just done is proved that that's what my answer is negative 1, 5. Now, all we've done is use the skills from Chapter 2 to help us with material from Chapter 3. So that's what you guys are going to be working on your homework tonight.